Good morning, everyone. Happy Monday to you. So from last week, we're in a unit about regular polygons. We talked about that last week, and we also introduced the idea of the apothem versus the side length versus the radius idea. So we talked a little bit about that last week, and we're going to use that today to talk about area. Again, they have to be regular polygons. So remember that when we say regular, that means that all the sides are the same, right? And all the angles. And when I refer to the angles, I'm talking about the ones that are at each vertice, right? So all the angles are congruent. It has to be regular, right? If it's not, then we've got a problem. Okay, so we've got two ways that you can do that. So the first method, I can find the area. I can split it into congruent triangles, and then I can take however many there are and multiply by the area of the triangle. Okay, so on my shape, I would have 1, 2, 3, 4, 5, I would have 6 congruent triangles. And so on this one, I would have 6 multiplied by 1/2 base times my height, right? So just 6 times the number of triangles. Now, notice that the base, right, is really a side length. And the apothem is off of the center, and we drop that down, right, so that it hits at a perpendicular angle. So we create those right triangles. So again, if I don't know angles, I can use that to find them. I can use my trig. Okay, so again, lots of things to think about. The other thing is that, remember, we can inscribe that in a circle, and so each one of these are those radii. So just, again, things that we're thinking about from that last unit or from the last section that we did last week. The other thing that can happen, right, so maybe that's not what they gave you. You can also, right, perhaps they just give you an apothem. You can also simply go 1/2 times the apothem times the perimeter. Okay, so again, we would remember it has to be regular, so all of these would be the same. Okay, so you can do it either way. It just depends sometimes on what they've been given, on what's been given to you, excuse me. Okay, so for your first example down here, right, so if I look at number 1, again, they have to be regular. Okay, so they have to be regular polygons. So the formula and the answer, we're going to round as necessary. But again, if I can do it without rounding, if I can use a special right triangle, I need to you actually are expected to do that. All right, so as we look at this guy here, okay, I'm noticing I have an apothem. Okay, so again, if we were to kind of sketch out that circle, this would be the apothem versus this right here. This would be a radius, okay, because my circle would go around here. These guys would be kind of those radii. Because I have an apothem and I know that all my sides are going to be 12, I think that for this particular example, it might be easier just to use method 2. Right, so my area would be equal to 1/2 multiplied by my apothem, which should be a 3.5, multiplied by my perimeter, which would be 12 plus 12 plus 12. Now again, you could write 12 times 3, you could throw in the 36, does not matter at all, but that would be the idea. So then we would have, get rid of that, 0.5 times 3.5 multiplied by 36. All right, so my area is going to come out to 63. I'm going to go ahead and put in just unit squared, just to remind ourselves that had there been a unit, we would want to make sure that was squared. Okay, now as I look at the next one, so again, our shape here, I've got 1, 2, 3, 4, 5, 6, 7, 8 sides, octagon. It's got to be regular. So again, I'm noticing they gave me an apothem, right? So center to side at a right angle, that's an apothem. And they gave me a side length. So method 2 is probably going to be the easiest. So we'll switch colors. So area is equal to 1/2 apothem multiplied by the perimeter. So this would be 7.5, and again, there were 8 sides. And that would be our area. So again, 0.5 multiplied by 9, and then 7.5 times 8. That looks like it's going to come out to 270. And again, we'll call that units squared, just in case. Okay, then we're going to look down at the other ones. Okay, so a little bit more work on these, right? So they did not give us an apothem. We've got some side lengths, but it's not going to be particularly helpful. So things that we're going to think about. If I go ahead and I put a center in here, again, I appreciate that's probably a little off, but here we go. If we go ahead and create some triangles, There we go. So again, as I'm looking at it, I've got 8 triangles. So let's think for just a second, see what we want to do. All right, so as we're thinking, we're going to remember, okay, if I were to go all the way around, right, that would be 360 degrees. I know that I have 8 triangles. So if I take 360 and we divide by 8, that's going to get us each one of those little angles. All right, so 45. So what we know right now is that each one of these guys, 3, and I appreciate that mine don't all look the same, but each one of those, right, is going to be 45 degrees. Okay, so that's a great start. Then what I'm going to remember, okay, is if I go ahead and drop an apothem, right, or the height and altitude, we're going to say, but so if I want to go from the center, I'm going to go straight down, right, that's going to hit at a right angle. Remember that when I do that, right, this is an isosceles triangle, right, both of these sides would be radii. Again, if I were to inscribe it in a circle, both of these would be the same length, which means I have cut the angle in half. So if I take 45 and cut it in half, that's going to get me 22.5 degrees. That's each side up there. Okay, that is not a 30, 60, 90 or 45, 45, 90. I'm not going to get a nice number here, but that's okay. I can still use my trig. So if I want to find my apothem, I'm going to go ahead and label that A. Recall that what happens when I drop my apothem, I'm going to cut my side in half. So instead of 2 inches, I'm looking at 1. Okay, so each side would be 1 inch. And I'm curious about that apothem. Well, from my angle, this side would be opposite, and that side would be adjacent. So I could use a tangent, right? If we remember SOHCAHTOA. Opposite and adjacent would be a tangent. So when we write it, remember we start with our trig function. We put our angle next to it. Opposite would be 1. Side I don't know, the apothem, that would be the A. All right, so to get the A out of the denominator, we go ahead and multiply. So A times the tangent of 22.5 is equal to a 1. And then to get A by itself, we're going to go ahead and divide both sides by 22.5. I'm sorry, tangent of 22.5. Sorry. So A should be equal to, again on our calculators, all right, we've got 1 divided by tangent 22.5. Looks like about round to the nearest tenth when necessary. All right, so we've got 2.4. That's going to be my apothem. Now, at this point, you could use either, because if you have an apothem, you've got 2, you could absolutely find the perimeter. Because I haven't used the other method yet, I'm going to go ahead and choose that one just so that you've got it. So if we use method 1, my area would be equal to the number of triangles, which would be 8, and then I multiply by the area of each triangle, which would be 1/2 times the base times the height, which would be the apothem. Okay, so again, if I use method 1, I would have 8 multiplied by, sorry, you should probably be able to see that, 8 multiplied by 1/2 times 2 times 2.4, which should get us 19.2. On this one, we actually had units, so we'll go ahead and put inches squared. Now, if I'd wanted to do the other way, that's 1/2 times the apothem, which we found was 2.4, multiplied by the perimeter, which would just be 2 times 8. Also 19.2. So see that it doesn't matter which one you use. You can think about it either way. All right, but the trick is going to be remembering that trig. Okay, so for part B, last example before we set you loose on the homework, same idea, right? So I'm going to put my center in the middle here. These, right, those would be the radii. And so this is going to be my apothem right here. Okay, so once again, all the way around would be 360 degrees. So if I take 360 and divide by 3, that's where I'm going to get 120 degrees. So 120, right, is each one of these great big angles. But when we take 120 and cut it in half, right, so 120 cut in half gets us 60. which means that the angle right up here, which I appreciate it, but the angle at the top is 60 degrees. If that's 60 and this is 90, that one's 30, and now you have a 30, 60, 90. When you have one of our special right triangles, it is expected that you go ahead and keep things in exact form, right? So for better or for worse, you're expected to do that. So what we want to remember about a 30, 60, 90, again, some of us like boxes. I'm not sure. I'm going to do boxes just in case. So you had 30, 60, 90. 30, across from my 30, that side was the x. Across from the 60, that was going to be the x root 3, and then 90 was 2x. All right, so on our picture, right, I have, now again, 5 was the whole thing, so that's going to be cut in half. So this one's going to be a 2.5. So I have the side that's across from the 60, right? So this would be 2.5, which I'm going to write as a fraction because it's going to make our lives easier. Okay, so that one's going to be 5 halves. But remember, when we're solving, 5 halves equals x multiplied by the square root of 3. So we have to get that square root of 3 by itself. So I'm going to go ahead and divide both sides by the square root of 3. Right? Or multiply by 1 over the square root of 3, however you want to think about it. Okay, so I went the wrong way, but that's okay. So I'm going to have 5 over square root of 3 times 2. But you are an excellent algebra student, and you are not allowed to have square root of 3 in the denominator. So you had to multiply by the square root of 3 over the square root of 3. So you're going to wind up with 5 square roots of 3 over, the bottom will be 3 times 2, and so we're going to get 5 square roots of 3 over 6. That's x. Now, to find the 90, I take whatever x is, and I double it. Okay, so I'll put that one up here. I'm running out of space here. So we're going to have 2, or 2 over 1, multiplied by 5 square roots of 3 over 6. Now, the 2 and the 6, I'm allowed to reduce those, right? So this would really be a 3. So I'm going to wind up with 5 square roots of 3 over 3. That's going to be my hypotenuse. Okay. All of that to find the area. All right, so my area formula is equal to, I can either do my triangles, okay, or you can absolutely do the perimeter, because again, we would have the perimeter for this. So it is absolutely your choice. I guess since I did triangles last time, I'll do the perimeter one this time. So my apothem, if I use my perimeter, would be my area, if I use the perimeter. 1/2 times my apothem. Now, the apothem in this case is across from the 30, right? This is my apothem, this guy right here. All right, so I'm going to have 5 square roots of 3 over 6. And then my perimeter would be 5 times 3. Okay, so remember, I want to leave it in exact form. So I'm going to go across, right? So in my numerator, right, I would have 5 square roots of 3, and then I've got times that 15. 5 times 15 is going to get me 75 square roots of 3 over, and then I've got 2 times 6 times 1, so over 12. Now, we want to be sure that that 75, that it doesn't reduce. So again, I'll take 75 divided by 12, change it to a fraction, and so our very best answer is 25 over 4 square roots of 3 meters squared.